Alright, I want to finish up the tutorial for the Game of Life assignment, and we only have two functions left to write. There's the perform lifecycle function and the get live neighbors or get num live neighbors function. And this one is actually going to rely on this one. So we won't really be able to test it until we get both of them written. So let's start with the perform lifecycle function. I'm just going to add a little space down there, and it says we need to iterate over all of the cell locations using a nested for loop. So I can just set up one of those for int row equals 0. Let row go all the way to the last row in our grid, so that would be grid.length, and then increase row by 1 each time. Okay. I also need to go over each column of every individual row, so we say for int col equals 0. I'm just choosing the name col. I could call it column or anything else if I wanted, but let's make col go up to the last column of that particular row we're looking at in the grid. So we can plug that in there and say go up to that length, and then we can say col plus plus. There we go. So what this allows us to do is access the current value at that cell, at that row, and at that column in the grid. So let's store that, and it's going to be a char, right? A character. So we'll say char c or current spot value or whatever you want to call it. Anyway, char current equals grid at row col. Okay, and this is important. We have to know what the current value is because it tells us for each cell, any live cell has to have 2 or 3 live neighbors to survive. So we can do that really quickly. We can say if that current cell is alive, and we know if it's alive if it equals a 1, right? So if it's a 1, then we can check if it has 2 or 3 neighbors, it says, that are alive. So maybe let's also, before we start our conditional checking here, let's save a little reference to how many neighbors are alive. We can do that by saying int num neighbors equals, and then we're going to have to call this function here, get num live neighbors, even though it's not written yet. We know that eventually that's going to tell us how many neighbors each cell has that are alive. So we just have to pass in what row we're looking at, what column we're looking at, and the grid, the data structure we want it to look inside. So the row, of course, is the row that we're currently looking at in the lifecycle function. So pass that row in, pass the same column we're looking at in. And then the data structure we want it to look at is the copy. The reason I have a grid copy is because I'm going to be making changes to the actual grid throughout each life cycle. So during the life cycle, I might have changed something already, but I want it to look at what it currently was at the beginning of this life cycle. So that's what grid copy allows us to do. So we pass grid copy in there. Oops. Okay, so we've got the number of live neighbors. We can say if, in this case where the current cell is alive, if its number of neighbors equals 2, or num neighbors equals 3, then it stays alive, right? Do nothing. Otherwise, and actually we're not going to be able to do a single line if statement there without doing brackets and also have an else there. So maybe let's put this in a bracket. This might seem like an unnecessary block of code because, as you can see, it's not doing anything. But that enables us to use an else statement where it will do something. So in the else case, it means it doesn't have 2 or 3 neighbors, therefore it should die. Or we should kill this current cell. So we can say grid at row col is now equal to the character 0, meaning it's dead. Okay. Now you might notice that this is not the most efficient way to do things, right? We could turn all of this into a single if statement if we wanted to. We could just check if it's not equal to 2 and it's not equal to 3, kill it, right? But I'm going to leave it like that just because it's easy to understand, even if it's a little bit more code than we would need. So then we can set up the case where it's not a 1, meaning it's currently dead. So we can say else. That means it's currently dead. Cell is dead. And the only way that we get to bring it back to life, if we look at this, dead cells with 3 live neighbors come to life. They become a live cell. So let's just do that. Oh, and the last condition is just saying every other type of cell dies. And we're already handling that by only handling the cases where it ends up alive or changes to be dead. Okay. So let's say if current cell is dead, we just check if num neighbors equals 3, and that's where it gets to come back to life, right? So we can say, in that case, grid row call equals 3, or sorry, equals 1, comes back to life. Only when there are 3 neighbors that are alive. Okay. I think that's all we need for the perform life cycle function. Let's just make sure the get num live neighbors function actually returns the correct value, because if you notice, it only returns a -1. No matter what we give it, it's always going to return a -1 right now. So let's change that. Let's set up a new variable called num neighbors or num live or something. We can say return num live. Or maybe better to say a number alive. And then we can go through each. Oh, what did I do wrong? Oh, it might not have been given a value, right? We got to start that out at 0. And then we go through each of the neighbors at a particular location. And we say, is the value at that location, or the location of the neighbor, is that alive or dead? If it's alive, we add 1 to this variable. Okay? So if current spot is at row and column, let's just look to the right of that. So we can say if grid copy at row, and then to the right of it would be call +1. If that equals a 1, oops, column. If that equals a 1, then we can say num alive ++. So that's the right neighbor. In fact, we can put a little comment there saying right neighbor. We can also check the left neighbor really easily. We can say if grid copy at row and then column -1 equals 1, then num alive also goes up, and that is the left neighbor, right? Left neighbor. Okay. I'm just going to copy and paste this and make it work for the top and bottom neighbors. So that would be dealing with row +1 and row -1 instead of column +1 and column -1. So this is the case where it is the bottom neighbor. Row +1 means you're 1 row further down, and then the top neighbor is where you're 1 row further up. So row -1. Okay. So that's half of the neighbors we need to look at. The other half are the diagonals, or the corners. So we can try, maybe just copy all those and then check the condition top right and top left and bottom right and bottom left. So let's change things around so it actually does what the comments here say it's going to do. So top right should be row -1, column +1. That's good. Top left should be row -1, column -1. Bottom right should be row +1, column +1. Bottom left should be row +1, column -1. I think we've handled all the cases. Now, here's the problem. If I run this right now, it's going to have some out of bounds errors because at some point it's probably going to have a current cell that's on an edge. Let's say it's at the very top, so row equals 0. Well, when it tries to go above that to look at the top neighbor of row 0, that's a location that doesn't exist, so it's going to give you an out of bounds error. So our solution for that, well, let's just verify that it gives us that error first, then I'll tell you the solution. So see, we got an out of bounds error, and it's right at line 115. So it looks like it's trying to go left of the farthest left position. Can't do that, obviously. So let's set up some constraints. We'll say only deal with them when they are not on an edge. We can say if row is greater than, or sorry, if row is less than 1, that means it's on the top edge, right? Or if row is greater than or equal to the last index, which would be grid copy dot length -1. So that means row is out of bounds, or row is on a top or bottom edge, right? So in that case, let's just return early. We'll just return 0. And then we can also set up a case where it's on the right or the left edges, and then also return out of that. So that would be column less than 1, column less or greater than or equal to grid copy at row dot length -1. So in those cases, we just exit early. And I don't remember which file I have it reading right now, or what the data looks like. Let's take a look at grid data. So here's going to be a problem. If our top edge is completely ignored, our initial state of the grid has something on the top edge. So I'm going to include another row of empty cells. Let's try it again. And let's see what we got. Oh, I think it's working. I just need to pull this output window up. There we go. Yep, so let me run that again. So you can see this is the life cycle. Through each iteration, it's changing. And eventually it gets to a state of a still life where it can't change anymore. So there you go. All right. I wonder how long this video was.